what we learned yesterday. So recall yesterday that we reviewed how to factor and then solve those factors, and then doing that we reviewed the quadratic formula and complex roots, and then we got on to dividing polynomials. So just a quick review of what we did yesterday. If I'm given polynomial function, pen's not writing where I want it to. Given the polynomial function x cubed minus x squared minus 7x plus 9, I'd like you to determine, first of all, when p of x is divided by x minus 3. So remember yesterday that we learned a couple ways of doing that. We learned long division, and we used synthetic division. You can do whichever one you feel comfortable with doing. So synthetic division, recall, is only working with the coefficients. So if I want to write down my division for synthetic division, I have to make sure this is in standard form, which it is, and I have to put in zeros anytime I'm missing a term. I'm not missing any terms in this case, so I just write down all the coefficients. I draw my synthetic division box. I identify my A value. What's my A value in this case? 3. Remember, it always has to be x subtract the A value. So my A value is 3. Then to fill in my synthetic division, it's very quick, right? Remember, it's different than long division. Gives you the same answer. It's a different process. Bring down to 1. 3 times 1 is 3. Add, I get 2. 3 times 2 is 6. Add, I get negative 1. 3 times negative 1 is negative 3. Add negative 6. So this very last line, remember, gives us our quotient and our remainder. Here's our remainder, and here's our quotient. So when I write down the division statement is a statement of equality between the dividend, which is equal to the divisor multiplied by the quotient and added on to the remainder. So just a quick review of synthetic division. You can do this by long division if you prefer. You never have to use synthetic division. Okay. What does that mean to do? If I want to determine p at 3. You know the answer? Raise your hand. Yeah.
If you want that to be actual answer.
No, just how, well, like, what does that mean? P at 3.
Every time you see an x
Into the polynomial, right? Excellent.
Okay.
So I'm going to figure out p at 3 by substituting a 3 and proper bed mass. I'm getting people on tests not using bed mass. Make sure that you do. Simplifying, that works out to be 6. So I don't know whether you noticed, but I took the A value and I plugged it into the original polynomial. I did that for a reason. When I did this, I got an answer of 6. Where does 6 appear in this page? Yep, it's the remainder. And that will always happen. When you plug in the A value into a polynomial, it'll always give you the remainder. That leads to something called the remainder. So the remainder theorem simply says if you can identify the A value and substitute it into the polynomial, then when you do some math and simplify, the answer is going to be the remainder. Okay, so it gives you the remainder without dividing. So when a polynomial p of x is divided by a binomial, is divided by a binomial, x minus a, then the remainder is p evaluated at that a value. Just an extension of what we did yesterday, because we learned yesterday also you can use synthetic division if you had a number in front of this x. Okay? So if I have a polynomial and I divide it now by a binomial, but the binomial has a number in front of the x, I don't need that dot there. What did we do to get rid of that number in front of the x? What did we do yesterday? Yeah, right, we factored it out. So if I factor this guy out, which I'll just do up here, I end up with that. So when you plug in the a value, which is now this b over a, that's going to give you the remainder. Then the remainder is p evaluated at b over a. Remainder theorem, all it's saying is you can get the remainder without dividing. Okay, so using the remainder theorem, determine the remainder if the polynomial is divided by the binomial x plus 2. So the remainder theorem simply says if I want to know the remainder, because that's all I care about here, if I want to know the remainder, if this guy is divided by this guy, I identify the a value, which in this case is what? -2, I plug it into the polynomial, that'll give me the remainder. Okay, and again, I can't stress enough proper bed mass. I'm getting people on tests. And at this level, for you, I really shouldn't be getting this. People evaluating this like 2 times 2 is 4, then to the power 3. Okay? Remember exponents first. So this would be -2 to the power 3 is -8. -8 times 2 is 16. Minus 2 squared, actually plus. 2 squared is 4 times 8 is 32. Plus 7. So what does that all add up to? 39, 55. Check my math, just make sure I'm correct. Okay. If you get a question like this on a test, and you very well might, if I ask this question right here, and you use long division or synthetic division and get the remainder of 55, how many marks do you think you're going to get? Yep. Yeah, none. You didn't answer the question I asked. Okay, the question is using the remainder theorem. So if I ask you to use the remainder theorem, you have to use the remainder theorem. Okay? It happens every year. I'm going to get people that are going to divide and expect marks for it. Okay? Answer the question that's being asked. Okay. So now that we know the remainder theorem, you have all the knowledge in order to answer this question. So I'm going to write it up there. I'm going to give you a second to think about it, and then I'm going to ask how do we solve it. Anybody have any ideas of how to solve this, or where to begin even? Jordan.
So you can make two equations, one that one is just 12, the other one, -3 equals 4.
Okay, so what you're saying by that is if I take 1, which is the a value in this case, and I plug it into the original polynomial, I should get the remainder, right? And you set it equal to 12? Perfect, so let's do that to start with. So Jordan realized that if I plug 1 into the polynomial using the remainder theorem, that allows me to determine the remainder, but they gave me the remainder as 12, so I can set it equal to 12. Does that make sense? Okay, so now I'm just going to simplify. So I get r plus g plus 5 is equal to 12, and I get r plus g, bringing the 5 over the other side properly, and I get r plus g is equal to 7. So all I know at this point is r plus g is equal to 7. I don't know what r and g are, but what Jordan was saying is I can come up with a second equation because it gave me some information here that if I substitute in -3 into the function, it'll give me the remainder of -20. So that allows me to set up a second equation. So r, -3 goes in for the polynomial. And that's equal to -20. Simplifying, I get -27r plus 9g. -12 plus 1 is -11 is equal to -20. -27r plus 9g is equal to, bring the 11 across, becomes positive, and I get -9. So now I get a second equation. You can now divide everything in the second equation by 9 because it's all divisible by 9, and it has an equal sign. That's why you don't have to factor. You can divide. So if I divide everything by 9, I get that. And again, so this is the type of stuff that I would expect you just to know how to do because you first learned this back in grade 10. You have one equation, you have a second equation, you have two unknowns. You have to solve two equations and two unknowns. And how do we do that? We've learned 3 methods in order in which to do that. You can choose any one you want. Okay? Or anybody else have them up? Elimination, or the less useful one, the first one you ever learned. Yeah. Or you could use one, so I'll throw in 4, trial and error works. And the other one is graph it. You can graph it, the 2 lines, and find out what it crossed. Okay? So it doesn't matter which one you use. I'm just going to write down the first equation underneath. And I'm going to use elimination because the g's already have the same coefficient. So if I subtract these equations, I'll eliminate the g's. So -3 subtract r, -3r subtract r is -4r. G subtract g is 0. -1 subtract 7 is -8. Divide both sides by -4, and it works out that r is equal to 2. And if I know r is equal to 2, then I can put 2 up into here, and I get 2 plus g is equal to 7. Solving for g, I get g is equal to 5. So I've determined my 2 values using the remainder theorem. Pretty good question. If I was making up the tests, and I made up all the tests in this course, I might want to put this one up. Okay, next one. Without dividing, determine x minus 2 is a factor of So without dividing, I want to determine if this is a factor of this polynomial. Remember we talked about what a factor was yesterday? A factor means that it goes into it evenly. So what would the remainder be? Yep, 0. Okay. So how do I determine if the remainder, when I divide this guy into here without dividing, if the remainder is going to be 0? How do I do that? Into the right. Okay. So you substitute your a value, which is 2, into the polynomial. To do some math. And you figure out that the remainder is 0. So since the remainder is 0, that tells me that this binomial went into this polynomial evenly. So therefore, x minus 2 is a factor of p of x. And really what we're doing there is we're using something called the factor theorem. The factor theorem is just an extension of the remainder theorem. And all it simply says is this. Extension of the remainder theorem. So the factor theorem says a polynomial p of x has a factor x minus a. I'm a terrible, terrible speller, but I can spell the word if. Why did I put 2x here? Anybody know what that means in mathematics? Okay, so what that means is a quick way, and we're always trying to mass shorten things, so this stands for if and only if. Okay, so this is saying a polynomial p of x has a factor of x minus a if and only if p of a is equal to 0. Now that if and only if is a very strong mathematical statement. What it means is it works both ways, meaning if p of a is equal to 0, then you can say this is a factor, or if this is a factor, then you can say the remainder is going to be 0. Seems like common sense, but that doesn't always work in mathematics, okay? Especially for any of you guys who go on to university math. So the factor theorem just saying, it's just the extension of the remainder theorem. It's just saying if you get 0 as a remainder, then it's a factor. Okay? How is that useful? So for all of you who love factoring, now we can factor any polynomial. Okay? Because up until this point, if I gave you a question like this on a test, and I said factor it, this has 4 terms. The only way you could factor a 4-term polynomial up into this point would be to do what? Okay. Group it. Okay, so I'm going to group it in red here, so because it's not going to work, I just want to show you it's not going to work. So to group it, you would group it 2 and 2 or 3 and 1. Common factor out. You'd be left with that. Common factor out to 9. You'd be left with that. Okay, but remember before when we grouped it, this bracket and this bracket would match, and you'd be able to factor it out. In this case, it doesn't have to. Okay. So we have to come up with an alternate way of factoring this. This is what we're using the factor theorem. The factor theorem says, if I can find a binomial x minus a that goes into it evenly, then the remainder is going to be 0. So all I have to do is come up with this a value that I can plug into here and get 0 as a remainder. That's the annoying part. Where do I get that a value from? Yes? Exactly. Okay? And that's, everybody comes up to me, is there an easier way of doing it? How do I know which one works? You don't. Okay? You just have to guess. The only thing that is saving grace is it has to be, you're guessing factors of the constant term, of your a to 0 term. So in this case, the only thing that can work are numbers that go into 9. So 1 plus and minus, 3 plus and minus, and 9 plus and minus. So there's 6 ones, one of them is going to work. Okay? And on a test, I would, if I were you guys, I would start at 1, -1, and then go work your way up, because I don't want you guessing the entire time. So when I made up the test, I made it up so that 1, -1, 2, or -2, 3, or -3, one of those would have worked. Okay? So I don't want you guessing the entire time. Okay, so now this is where I said synthetic division is going to help you out in your factor. Because when this question says factor, and in the textbook it'll say factor using the factor theorem. What they're asking you to do is to guess an a value, plug it into here. If you don't get 0, guess another a value, plug it into here. If that doesn't work, guess another one until you get 0. Then when you get 0, take that binomial, use long division, and divide it out. Okay? What I'm telling you to do is to use synthetic division because it's much quicker. Guess a value here, because if you get it right, then you're halfway done the question. You've done the division. Okay? Do you guys understand the difference? What I'm talking about? Okay. You can do it either way. It doesn't matter to me. If you like more work, do it that way. Right? If you like to be lazier, like myself, do it this way. Okay. Guess a value. You guess something. David, give me a number. 1. So you try it. As soon as you realize it's not going to work, just stop doing it. So this right here is 20, right? 29, 20, it doesn't work. Okay? Next one you try, I'll try -3. 1, because I know it works, and we don't have to waste any more time. Okay? So bring it down. See, now when I've guessed here, instead of having to go back and once I figured out one that worked and have to divide it all out, I'm halfway done the question, right? Because when I used -3, I took my division statement, which was not took the division statement, but writing down the division statement. When I used -3 as my a value, what binomial was I dividing by? Yeah. X plus 3. And when I divided by x plus 3, I was left with this quotient, which represents 4x squared plus 4x minus 3. So writing the division statement is really what I'm doing is I'm factoring. So I've taken this polynomial and I've written it as a product of a linear factor times a quadratic factor. What do you think you do next? If I want to keep factoring. Yeah, you factor the quadratic, right? So you can factor it's a hard type trinomial. So factoring the hard type trinomial.
Excuse me, Mr. Hoffman.
Yes.
I'm sorry to interrupt. I'm looking for Kamar Ali.
Yes, he's here.
Would you ask him just to sit down in the office for a moment, please?
Yep.
Thank you.
Okay. So now when I factored this as a hard type trinomial, now I've factored this expression. So I knew -3 worked. -3 is one of my answers because of x plus 3. What other two values would have worked? Okay. How did you get that? You're right. How did you get that? Exactly. So factoring out the 2 there, I would have got -1/2, so 1/2 would have worked. And here actually -1.5, -3 over 2 would have worked. Okay. How possibly would I have gotten those fractions? Okay, because those fractions weren't even the possibilities of 9 here. Okay, so if you're excited about that, you're going to have to wait till Monday, and then I'll tell you how to do that on Monday.